In this lecture, we will take a look at arrays. Arrays are very similar in C++. Arrays in Java, there are some very important differences though. So the basic idea is the same, but very important differences. Okay, so we will take a look at basic use of arrays. So you will see that there are maybe some superficial differences, and then there are some deeper differences in the way arrays are managed. In C++, you have a lot more freedom over what to do with arrays that you don't have in Java. Behind the scenes, though, Java arrays are actually objects, and they have a lot more functionality. And C++, they are just raw memory. It's a little bit more basic in structure. So the structure is very basic. And we'll see the differences pretty soon. So we'll look at the introduction to arrays. I won't spend a lot of time on this. I will concentrate on the differences between arrays in Java versus arrays in C++. Okay, and we look at arrays as function arguments, as arguments to functions, as return values. Well, actually, we won't look at that in this chapter. That's coming up down the line, in about chapter 10 or so. We will see how to return an array from a function. And we look at programming with arrays, maybe a quick look at multi-dimensional arrays. Okay, what is an array? An array is a collection of data of the same type. So if you have an int array, they're all ints. You can't put a double in one of the locations. And so this is one of the simplest, usually the first aggregate data type that you usually see. That is first data type that has multiple components that are aggregated together. In this case, they're all collection of the same type of data. And so we started out you probably started out in CS 161 and 162 with int arrays and then float arrays, double arrays. These are all simple data types. And later on, we'll look at arrays of objects. So that's coming up, not in this chapter. We use this for list of items of like items, that is list of things that are all of the same type. For example, list of test scores only, list of temperatures, list of names, things like that. And we won't get into strings quite yet. We want to go through arrays, and after that we'll be ready for looking at strings. So right now we'll try to stick to the basic data types, simple data types. How do you declare an array? So here we see a very sort of superficial difference between Java and C++. Java, you cannot do this. You cannot say int, then array name, and then the square brackets with some number in them. In C++, you can. So this declares an array and allocates memory for it. And we'll get into some of the details later, but this means whenever you see something like this, it means that you are allocating memory from an area of memory called the stack. In Java, we cannot do this. We cannot allocate an array on the stack. We can only allocate memory using the new operator or the new keyword in Java, and that allocates memory from the heap. That's a completely different area of memory. And in C++, we can do both. In Java, we can only do memory allocation using new from the heap. C++, we can allocate memory for an array on the stack like it's done here, and that's all we will talk about right now. So we will talk about a way of setting up arrays that does not exist in Java. This sets up an array of 5 ints, and the name of the array is score, and you can access the 5 different locations by using indexing, just like in Java. It starts with 0, score sub 0, and I will use the term score sub, meaning index 0, score index 1, or score sub 1, and so on. Okay, so notice that there's many individual parts, and they're each called something different. So score sub 0 is distinct from score sub 1, but they can be treated as part of a whole array, whole thing called score. Okay, so these are the elements of the array. They're accessed by indexing or subscripted variables. It's the same idea in Java. You can print them out, you can assign values to them, you can use them as parts of expressions and so on. So use the square brackets just like Java. So nothing different about use of arrays here. So this is a powerful storage mechanism, allows you to automate, a whole bunch of things. So now this will be the same as in Java. I'm going to skip all of this. And looking at that simple example, whenever you see an array, you can guess that there will be a for loop somewhere close by. In Java, we have a couple of ways of writing for loops. The usual one is the for int I equals 0, I less than 5, I plus plus, or in this case IDX. And then we also have the enhanced for loop. The enhanced for loop, there is something similar in C++, but it is different enough, and we won't run across it right now because it is a new feature of C++ 11. That is the C+ version of C++ that was introduced 2 years ago in 2011. And we can use it if you're using the Linux live DVD or the version of Eclipse that came with that. Then we can use the enhanced for loop. But I'm not going to go over it right now. Those of you who haven't seen the enhanced for loop in Java, don't worry about it. We're going to probably see it later. All right. So once again, for loops, natural way of interacting with arrays in programs. There is one thing. Here's another thing that's different between C++ and Java. That is that it's up to the programmer to stay in the range, in the valid range of valid indices. So C++ will let you go beyond the range, and we'll take a quick look at that. This one can give you unpredictable results. The compiler does not warn you, and actually that's true in Java too. In Java, if you try to index beyond the bounds of the array, the compiler will not detect it, but when you run it, you get a runtime exception, out-of-bounds exception. There's no such out-of-bounds exception in C++. It really is more up to you to stay in range. If you go beyond the bounds, you might be able to go a little bit out of bounds, but eventually you will run into problems. Let's take a look. Simple example that'll do that. Okay, so I've set up a simple program. All it does is say we're going to have an array program, and here's how you want to set up an array. Rather than saying int a and then a number, you want to use so that would be what's called a magic number. That's just a number that appears from out of magically appears in the middle of your program. You don't want to do that. You want to say something like this: const int size equals 3y, because, for example, we use size in this declaration of the array and also in this loop. The alternative would be to not have this constant size, put in a 3 here, put in a 3 here, and then a 3 wherever you use the size of the array, and then you might forget what the size is and use something different, or you might change the size here and then the loop does not reflect that change in size. It's much better to have something like this, a constant size, so that if you do want to change the size of the array, you can change it here and everything else reflects that change, because that's much better. Okay, having said that, here's an array of 3 elements, and what we're going to do is write a simple loop, and this is the straightforward loop that we've always used in Java as well. And apart from the cout insertion operator, it's essentially the same as Java. So you can put in Java you would put a system.out.println a sub I, but it's the same idea. Alright, so let's just run this in. Let's not worry about this function right now. Let's compile this and run run it. Okay, so it prints out that message saying arrays, and I'm trying to slide it up. Okay, so it prints out arrays and then 3 zeros and something else that we're not going to worry about. Now, what can we do that Java probably will not let us do? We can do this. Java will let us write a program like this, but if this would mean that you're going out of bounds, you're going from 0, then you're going to 1 and 2, and then that's really all you're supposed to be able to go. But if you set I less than or equal to size, then you will also try to print out a sub 3 doesn't exist here, because remember, this is a common pitfall to avoid in Java as well. That is, the array indices always start with 0. And so if the size of the array is 3, then you can go from 0 to 3 minus 1, which is 2. So 0 is the first number to computer scientists. And and so for arrays, this means that you go from 0 to size minus 1, whatever the size of the array is. C++, like we saw, will let you go beyond the range, and actually so will Java. But in C++, you will get unpredictable results, while in Java, you always get an out-of-bounds exception as soon as you go one beyond the bounds of the array. And the compiler, in either case, will not detect these errors. It is up to you, the programmer, to stay in range. Okay, so there's a simple example of this pitfall. That is, you declare an array of size 24. You think, okay, I should be able to go array sub or temperature sub 1, temperature sub 2, so on up to temperature sub 24. No, it goes temperature 0, temperature 1, and so on up to temperature 23. Whatever the size is, minus 1. So it's a common mistake to assume that you can do temperature sub whatever array size and then assign a value. This is out of range. The thing is, in Java, you always get an array index out of bounds. C++, there's no warning, no compiler warning, and you actually don't know what will happen. Very unpredictable in that way. So let's see what will happen. Let's take a simple example. We set the size equals to 3, and we'll actually go beyond the bounds. See if we get an array index out of bounds. I'm guessing not, because this is C++. Compiled it, we run it, and we go out of bounds. And in this case, we were safe. Now, I do want to note before I forget, in Java, whenever you declare an array and you allocate memory using the new keyword, all of the locations in that array is automatically 0. Now, it just so happened that we lucked out and got everything to be 0. But that is not something that you can expect. You can expect that if you do not initialize the locations of the array, then you can get unpredictable values. It just so happened we lucked out. Okay, so these are the actual locations of the array. Somehow we lucked out and got zeros in all of those locations. And in addition, what we did was we went beyond the bounds of the array and we printed out a sub 3. And for some reason we got a 3 there. And I have a feeling, I'm not certain about this, I have a feeling that this 3 came from here. So we are accessing something outside the bounds of the array. It just so, I believe, happened to be the thing that was declared just before the array. We can just do a simple test. Let's make this 2 and we should be able to check it out. Compile this and run it. Yep, it sure looks like it goes beyond the bounds of the array and then accesses the 2. So this tells us something about how these things are organized in memory.